Hello, let's take a look at binomial expansion. So this is an exam style question. So for part 1a, they ask us to write down the quadratic expression of 2x squared plus x minus 3 as the product of two linear factors. Actually, what they're asking of us is just to factorize this given expression. So 2x squared plus x minus 3 will factorize as 2x plus 3 and x minus 1. Now, this is the product of two linear expressions. So I can see here 2x plus 3, x minus 1. Those are both linear expressions. Then for part B, they say, hence or otherwise, find the coefficient of x in the expansion of this to the power of 8. So what I can do here is I can say, sure, 2x plus 3 to the power of 8 multiplied with x minus 1 to the power of 8. And now that I see here, I have the product of two binomial expansions. And they want me to find the coefficient of x. So basically x to the power of 1. In order for me to calculate or to find the x to the power of 1, I will notice that there will have to be an x in my first bracket multiplied with a constant from my second bracket, and vice versa. An x from my second bracket multiplied with a constant from my first bracket. So I can say, just to see, so an x term from my first bracket multiplied with a constant term from my second bracket plus the x term from my first bracket or from my second bracket multiplied with a constant term from my first bracket. So now we have to go and find these values. So I'm going to say that if I want to find this, and I'm going to use nice big square brackets. So for the x term in my first expansion here, I know that for the combination, so n is equal to 8. Now I have to find the value of r. X is in the place of 8. Remember, it's a plus b. And a will be n minus r. So if x is to the power of 1, r has to be 7. Because then it will give me 2x to the power of 8 minus 7, which is 1. And b to the power of r, so 3 to the power of 7. This multiplied with a constant term from my second expansion, and the only constant from my second expansion is negative 1 to the power of 8. Then I'm going to add the x term from my second bracket here, and again this is in the terms of a plus b. So if I want to find x to the power of 1, n is 8 and r is going to be 7 again. So it becomes x to the power of n minus r, which is 1, multiplied with negative 1 to the power of r, which is 7. This multiplied with the constant term from my first bracket. And the only constant term I will get from my first bracket is 3 to the power of 8. I can go and simplify this. I know the combination of 8 and 7 is going to give me 8. Multiplied with 2x, because 2x to the power of 1, multiplied with 3 to the power of 7, which gives me 2187, multiplied with negative 1 to the power of 8. But 8 is an even number, so therefore negative 1 will become positive 1. This plus, and again I'm going to have the combination of 87, this gives me 8, multiplied with x to the power of 1. But here, negative 1 to an odd power means it will stay negative 1, multiplied with 3 to the power of 8, which in this case will give me 6561. And I'm going to close my bracket. So if I want to expand this, or simplify this rather, then remember all of these dot, 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 because I only took the first terms. There are many other terms, but I'm only interested in these terms. So this will be 34,992x, if I wanted to, minus 52,488x, but I want only the coefficients here. So if they ask me for the coefficient of x, I can look at the constant, and then it will become negative 17,496. And there I have my answer. Here is another example of a binomial expansion. They asked us to expand and simplify the following. If I want to expand and simplify this, of course I can use my combination, so nr, and then I can say a to the power of n minus r and b to the power of r. Now instead of this combination here, I could alternatively use Pascal's triangle. So if I want to use Pascal's triangle, I can expand it down. Let's see here, 1, 2, I have 5. Okay, so if I see that the following bracket is to the power of 4, I know that there will be 5 terms if I expand it. So I go down in Pascal's triangle and I can see here 1, 4, 6, 4, 1. So I can see here I have 5 terms, and these will be the coefficients instead of these combinations in front here. So I can use both methods. It depends what you find easiest. So if I want to expand this, then of course I can go and I say, sure, my coefficients, I'm going to just use Pascal's triangle here. And now NR, it's good to know what to write. So in this case, N is going to be 4 and R is going to be 0. Now if I look here and I say that in the place of A, I've got x squared to the power of n minus r. N is 4, r is 0, so n to the x squared to the power of 4. Then b to the power of r, but this will now become negative 2 over 3 to the power of 0, so this will just be 1. So actually I could have written just here x squared to the power of 4 if I wanted to. Then for my second term, so I'm going to have 5 terms, I will just expand it. So I can see here from Pascal's triangle, I'm going to use my second coefficient here. Or alternatively, if I wanted to use combinations, it will be 4 and 1. So then I go and say x squared to the power of n minus 1. 4 minus 1 is 3. And then I'm going to say negative 2 over x to the power of r. R in this case is 1. Then I'm going to go for my third term. I'm going to try to squish it in here. For my third term, I can see here that I'm going to use Pascal's triangle, and I'm going to say that this is 6. Alternatively, I could have said that this would have been 4 and 2 for combinations. Therefore, it would have been x squared. 4 minus 2 is 2, and then negative 2 over x to the power of r, which is also 2. Plus, and then my fourth term, I'm going to say 4 again, Pascal's triangle, x squared to the power of 1, because 4 minus 3 is 1, and then negative 2 over x to the power of 3. And then of course my last term, or my fifth term, the coefficient is going to be 1. I'm only going to focus on the b part. It's going to be negative 2 over x to the power of 4. And I will see I have 4 terms. This is my first term here. 1, 2, 3, 4, 5. Sorry, 5 terms. Yes. Now let's go and simplify. So the first term I've already simplified as x squared to the 4th. Alternatively, I could have said this is just x to the 8th. Then this term here, so 4 times negative 2, and this will become negative 8 multiplied with x. Now x squared times 3 will become x to the 6th, and then x to the power of minus 1. Remember, it's 1 over x. I'm just going to write it here with a negative exponential. Then for my second term, my third term, so 6 multiplied with negative 2, and 6 multiplied with negative 2 is going, so it's negative 2 squared. So 6 multiplied with negative 2 squared, so this becomes plus 4 times 6, which will be 24, multiplied with x to the power of 4, because it is x squared raised to the second, and then here it will be x to the power of minus 2, because it is x to the power of minus 1. Alternatively, I could have rewritten this as x to the power of minus 1 multiplied with this 2 here, so x becomes to the power of negative 2. Then, so I have 1, 2, 3 terms. For my fourth term, here I'm going to say 4 multiplied with 2 to the power of 3. 2 to the power of 3 is 8. It's going to be negative, so negative 8 times 4 becomes negative 32, and then it becomes x squared multiplied with x to the power of negative 3. And then for my final term, I'm just going to squish it in here. So negative 4 to the power of 4 becomes 16. And of course, it is an even power, therefore the negative becomes a positive. Negative 16 x to the power of minus 4. Then I can go and simplify each one of these. So of course, just by exponentials, I'm going to say x to the power of 6 minus 1, so therefore x to the power of 5 plus 24x squared, because x to the fourth minus 2x squared, minus 32x to the power of minus 1 plus 16x to the power of negative 4. And these are all my 5 terms, 1, 2, 3, 4 and 5. Here we have another exam style question. This is going to be the third example from binomial expansions. So we are given brackets to the power of n, and they tell us that n is an element of natural numbers, and this is expanded in ascending powers. That means the powers will go up. Of x, the coefficient of x cubed is 70. Find the value of n. So we have to work backwards now. Normally we have to expand something. In this case we have to find to what power is this bracket raised. So I'm going to start off with so I'm going to say here 3a. I'm going to say that from my binomial theorem, so nr, a to the power of n minus r times b to the power of r. Let's see what do we have and what can we replace this with. So if I want to go and take a look here, I'm going to say sure. So my nth power, I do not know what it is. Then I want to find the r value. So they asked me the coefficient of x cubed. So in this case here, I see that this is a and b. So x is in the place of b, so this part here, and b is raised to the power of r, therefore r has to be 3. So I'm going to say here 3, then in the place of a I have 1 raised to the power of n minus r, which doesn't really matter because it is 1. 1 raised to the power of anything will stay himself. Multiplied with b, in this case it is a half x, raised to the power of r, which is 3. And they tell me that the coefficient of this thing is going to be equal to 70. Of course, first let's go and simplify this. So I'm just going to say n3, I know this, and then of course this 1 doesn't matter because 1 to the power of anything stays the same, and then I'm just going to say 1 over 8 because a half raised to the power of 3 becomes 1 over 8 x to the power of 3. So I can see here that this is going to be the term that I have, and this is going to be the coefficient in front of x cubed. So then what I can do is I can go and say sure, if I know that the combination n3 multiplied with 1 over 8, so this is supposed to be equal to 70. The coefficient is given. Now this 1 over 8 is actually n over 3 divided by 8, so I'm going to multiply with 8 on the other side. So n3, this combination, is equal to 560. So I will have to use my combination formula for this. So the combination formula for this states that it will be n factorial over r factorial, which is 3 in this case, n minus r factorial, and this is equal to 560. Now 3 factorial is 3 times 2 times 1, which is equal to 6. So this fraction here says n factorial divided by 6, but I can multiply with 6 on the opposite side, so therefore I'm going to say n factorial over n minus 3 factorial is equal to 560 multiplied with 3 factorial, which is 6. So 560 multiplied with 6 will give me 3,360. Then let's go and try to simplify this. So on my denominator, I know that n factorial is the same as, so I can rewrite n factorial as n multiplied with n minus 1 multiplied with n minus 2 multiplied with n minus 3 factorial, and this whole thing over n minus 3 factorial is equal to 3,360. Therefore I can see here that n minus 3 factorial divided by n minus 3 factorial is equal to 1, and therefore I am left with n minus 1, n minus 2. If I expand this, then I will get a polynomial. So n to the power of 3 minus 3n squared plus 2n minus, and now let's just bring the opposite, this to the opposite, to the left hand side, and I am going to get here minus 3,360, and this is equal to 0. And now I can solve this polynomial, this cubic, and if I solve this cubic, I will find that n is equal to 16. Of course, this is a very large number, so you can solve this on your equation editor on your calculator. So for part A, we have found that n is equal to 16. Now for part B, they ask us to find the coefficient of x squared. So I'm going to say 1 plus x over 2 to the power of 16, and they want me to find the coefficient of x squared. So I'm going to say that for my binomial theorem, nr, a to the power of n minus r, b to the power of r, I notice here that x is in the place of b. So I am going to say that n is equal to 16. r, I want the x to the power of 2, so r is going to be 2. Then I'm going to say 1 to the power of 16 minus 2, which is 14, and x over 2 to the power of 2. Then I can go and expand this, and the factorial for this is going to be 120, or so the combination for this will be 120 multiplied with x squared over 4, and therefore 120 divided by 4 is going to give me 30 x squared. They asked me for the coefficient, so we are interested in this 30 here.